Okay, welcome to the West Virginia Watershed Network's webinar series, Nonpoint Source Program Approaches to Reducing Fecal Coliform Pollution. This is the second of 5 weekly webinars that will provide tools and information to help watershed organizations reduce nonpoint source fecal coliform loads in streams. My name is Autumn Crow, and I'm the Deputy Director of West Virginia Rivers Coalition, and I also help coordinate the West Virginia Watershed Network. The West Virginia Watershed Network is comprised of nonprofits as well as state and federal agencies who support the work of watershed organizations across the state by providing resources and opportunities for collaboration. We are excited to provide this fecal coliform webinar series for you all. Before we get started, I just want to go over a few housekeeping items. We are using Zoom webinar for this training series, so attendees' videos are off and microphones are automatically muted. We are recording this webinar and will send the recording to registrants after the webinar, along with any relevant resources. Please type any questions you may have into the Q&A box found at the bottom of your Zoom toolbar. We encourage you to add your questions to the Q&A at any time throughout today's session. We'll have 2 speakers today, and we'll answer questions after each presentation. If you want to ask a question out loud, you can put question out loud in the Q&A box, or you can use the raise your hand feature and I will be able to unmute you. With that, I'll pass it over to Martin to introduce today's speakers.
Hi, my name is Martin Christ. I'm with the Watershed Improvement Branch in DEP, and I am happy to introduce James Summers, who is in the Water Quality Standards and Assessment section and is their source tracker. Sounds like a great job most of the time. I guess I don't know exactly what the name of the talk is, so I will just be quiet and let James take it away.
Okay, thanks, Martin. It is a good job most days, that's for sure. All right, so today's talk it's going to be practical thoughts for watershed groups on TMDLs and source identification, all related to fecal coliform bacteria. I geared this, I wasn't exactly sure who all would be in the audience, but I geared it for watershed groups, and I may leave some people confused and some people bored, but we'll have questions, and you'll have my contact information that you can follow up with. Email is the best way to get a hold of me if you need to do that. I'll give you my phone at the end, but I am either out of the office or when I'm in the field without cell service. So just shooting me an email is a good way to reach me. james.p.summers@wv.gov. So as Martin mentioned, I'm source tracker in the TMDL program, have been for over 20 years. I've been basically a field guy with, even before DEP came around. I was inspector in Department of Natural Resources when the Water Resources program was in DNR. So I've been poking around in the field for a lot of years and like it that way, and hopefully will continue for another few until retirement. So Martin asked that I address just a few things in particularly. I'll give you a heads up on those, that how TMDL allocations are made, what we do in our group as far as source tracking, and then what kind of work would a watershed group have to do to be confident you are tackling the right problems. Is it ag related? Is it residential related, or both? And I'm going to add into that to not forget public sewer areas. We'll talk about those. I think they'll play a prominent role in what we talk about today. And then also how bacteria levels have been reduced and kind of how we're monitoring that. So in a nutshell, I'll start out with a little TMDL explanation, and then the bulk of what I talk about will be pollutant source tracking, bacteria source tracking, and how to develop a sampling plan. And then I'll just touch on at the end implementation and follow-up sampling. So with that, I guess out of the gate, I think most people know this, but it's always good to be reminded. It's always good to remind my own self about it. But fecal coliform and E. coli both are indicator bacteria. So just because you have E. coli present in a sample, that doesn't mean that that the sample contains harmful bacteria necessarily. So CDC says most E. coli are harmless and are actually important to an important part of the human intestinal tract. So these indicator bacteria, fecal coliform and E. coli both, what they do indicate is that a contamination pathway exists. In other words, there's number two getting in the stream from one source or another. And that's what we can know from when we get a hit for those. The other thing I think it's always important to remind ourselves is that the fecal coliform bacteria samples, there's a lower level of accuracy, precision with these samples than with really any of the other analysis that we do in the environmental field. I pasted this table from a report I put together last year, and it shows some duplicate sample results from our database in DEP. And looking at that, I'll highlight one there. If normal circumstances or other circumstances, if I get a 600 on one result and I go upstream of there and get a 345, you would say that's a significant difference, but it's not uncommon to get that as a duplicate sample result in bacteria sampling. So the moral of that story is don't just rely on one sample or one set of samples when you're looking at the data. If I have 5 samples that show that same pattern, that's something I can hang my hat on. But just going out and getting a couple grabs in a single day with 2 different sources, it's not quite that simple. So our water quality standard itself is set up with 5 samples per month. It's not a one-time type of grab, with the idea that there's variability in the results, and the results can be pretty highly variable. So just practical tip number 1 there when evaluating bacteria results, don't assign too much weight to a single sample, and look at trends within multiple samples. So Martin also wanted me to touch base on sort of the scope or the magnitude of the fecal coliform problem in the state. And you're looking at a graphic here that shows miles of stream impairment by parameter. Fecal coliform, and I'm sure you can't read what's going down the side, but the second bar across, second bar down is fecal coliform. It's our second most common impairment. There are about 11,000 stream miles in West Virginia that have the fecal coliform impairment, or TMDL, issued for them, and that's roughly 30% of the state's waters. And if there's an impairment, the Clean Water Act puts us going down the road to do a TMDL on that waterway. So I'm going to take 5 minutes and do a TMDL overview. I'm not going to tell you what TMDL means, but I'm going to tell you that it's a plan to reduce excess pollutant loads. And it's a mathematical plan. It's based on a computer model. And it basically starts with the baseline, how much loading for a given pollutant is in the waterway now. Then the model will specify reductions in various categories of pollution so that the stream would, the model would calculate that the stream would again meet water quality standards. So with bacteria, these sources of bacteria categories, we're talking about things like pasture, failing septics, sewer overflows, urban and residential runoff, and background as well. We start out when we're doing a TMDL project, we will set anywhere from 250 to 300 sample stations out in a watershed and sample those monthly. So we've got a lot of results to calibrate the model to. We'll enter data in on specific sources, whether it's pastures or discharges from wastewater plants, whatever that may be. Land uses and weather data also is a big part of the model. So if you're looking at the world from above here, you look down and there are lots of different land uses, and the computer digitizes these, and then the TMDL model makes it rain on all these different land uses. And each land use category has set a default bacteria concentration, so that essentially the TMDL model makes it rain on these land uses. It plugs in discharge data from permitted sources, and then the model calculates the in-stream concentration at various points along a waterway. And then we're going to compare that to our target value and say, gosh, we've got a problem here on this stream. What do we do? And that's kind of where the real modeling comes in. And I think of the TMDL model as having knobs on it for each one of these categories. Now, hopefully this is a good analogy for you, but the person running the model can then turn the knobs to set various levels of reduction for each category. And so in this case, for failing septics get a 100% reduction, and failing septics always get 100% reduction in the TMDL. We always do up to this point in 20 some years, there's always a 0% reduction from background wildlife contributions. And then other things are reduced some level in between. So when those reductions are applied, our baseline conditions are reduced, and the model output then is predicting in this picture now that there would be no violations of water quality, and the stream would attain full use at that point. And that's a pretty simple concept for a TMDL, that there's the baseline, we apply these various reductions, and then until the model says we're meeting water quality standard. But when you look at the output of the model, it becomes a little more confusing than that. And I'm not going to go deep into the weeds here on these allocation spreadsheets, other than to say that they are the final product of the TMDL, and that they do. Let's see. We're looking at one tab of several tabs in the spreadsheet. This is the one for Nonpoint source, which is what we're talking about today. And we start with column E, so there's other information off to the left, off to the right. It's just too big to put on screen view. But off to the left, you would have like the stream name and subwatershed number. So this reference to a particular place in the watershed. But mainly I wanted to just mention here that all the categories of pollutants are laid out here in this allocation spreadsheet. So we've got pasture, we've got background, we've got the on-site septic systems, and the residential. And each one of those categories has 3 columns. There's the baseline, which we talked about, the beginning conditions. There's the percent reduction that's applied in the model. And then those two together, you come up with the allocated load when you apply the percent reduction to the baseline. And it's not just a random kind of approach when they're doing these allocations. There's a fairly standard approach that guides it. The first thing that's reduced is the on-site septic systems. And those are, like I say, those are cranked back to 0 contribution. So there's 100% reduction on those. But then pasture, especially the riparian pasture, what's right along the streams, That's the next thing that's reduced, and then urban and residential runoff. And background is in there, but it would be a rare thing for that to be reduced in the TMDL model. And just kind of I don't know, James's take on things here. Don't get caught up in the details of the numbers. The outputs of the computer model don't exactly match reality. It's a model. It's only as good as the calculations that are in it and the input data. And the real goal of everything we're doing is not to get, a 69.3% reduction in pasture runoff. It's improved water quality. That's the end game that we're really after. So when we finding the real problems and working toward improvements of those problems, that's the goal here that everything should be pointing toward. All right. And looking at the real world, there are lots and lots of sources of bacteria out there, right? There's good pastures and bad pastures, and cows in the creek, and feedlots along the stream bank, horses and deer in the fields. There's dogs in the front yard and chickens in the backyard, and non-compliant sewage plants, and manholes overflowing, and combined sewer overflows, straight pipes. There's just this whole gamut of stuff that's out in the real world. So the question is, how do we know that we're pointing at the right things? What's the significant problems in this watershed? What should we be targeting to work on? I'll mention just real quickly one hopefully practical application of the TMDL in the allocation spreadsheet. Not again getting bogged down in the details, but if you just look in this left column, is my laser pointer showing up, Martin?
Yes, it is.
Okay. So the pasture baseline, you see these numbers here, the 12s and 13s. That's the exponent for the annual load, but their order of magnitude is like 12 or 13, and you compare that to the on-site septic systems, which have a order of magnitude of, most of these are 14 or 15. So the TMDL is looking at on-site septic systems and agriculture and saying, gosh, in these watersheds, the failing septic systems are 100 times more of an issue than pasture. And if you went over and looked at residential, it's about that much lower. It's maybe, the model saying 100 times less than pasture. And I will say, I mean, this gives you a rough idea of where you can look, but I will say that I think, especially in a lot of the early TMDLs, really up for probably the first 12, 14 years of TMDL work, I feel like we overestimated the failing septic contribution and maybe underestimated the residential and urban runoff. And part of that reason is because leaky public sewer systems, not CSOs, but just leaks or overflows, are included in this residential urban runoff category. And that may be a new bit of information that's not real obvious in the name of things, but I feel like a lot of the old ones may have overrepresented failing septic systems and underrepresented contributions from leaky sewer systems where those systems existed. Okay, how to narrow down and quantify sources, and where sampling is going to play a big role, but source inventories should play a prominent role here too. And we'll talk about that, but I just say start with the existing data, and if you don't have existing data, ask DEP. I'll give you my supervisor's name here to call, but Nick Murray is he's been around for a while now, but the new TMDL manager. You may remember Dave Montali and Mindy Neal, but Nick has moved in to that position. in the last year or so. And you can call, and we're happy to share information with you. Two of the most practical things that you can get from all the TMDL work we do, I think the two most practical things are probably the actual stream sample results and the pollutant source report. But neither of those are included when you go on the website and look at the TMDL links. Neither of those are included. So that's something that you would need to call, get a hold of us to ask for. And again, you can email me if I'm happy to help you. I would be even glad to swing by and talk with you sometime in person and go over some things, to spend a couple hours together if that's helpful for you. So when you're inventorying, and gathering data, gathering information on what types of sources are in a watershed, don't assume that public sewer systems are not a contributor, especially if it's an older system. So public sewer systems, a big player, I think, where they exist. Private sewage systems, septic systems, I think most people are pretty familiar with them and their problems. Home aeration units and package plants are other non-public sewage systems, and both of those need chlorine tablets in their effluent for them to work properly, for the chlorine to disinfect and lower the bacteria levels. If the tube of chlorine tablets is empty, they're not providing any disinfection, and so you've just got treated but not disinfected water heading out to the stream, which obviously can be problematic. Pasturing, we'll look at some pictures here in a minute, but with pasturing, you're looking for areas where there's unrestricted stream access for the animals, especially for cattle. Horses tend not to stand around in the creek like cattle do. So if you cow pastures that have unrestricted stream access is something that you want to make note of, and also feedlots that are alongside a stream. And there can be just any number of odd occurrences that are out there. One watershed group was, I think they were concerned about a rest area where people stopped and had a dog walking area, and you just had an inordinate amount of dog droppings there, and in a little area at the head of the watershed. And I even ran across a situation where we had a DOH deer carcass dump, along a 4-lane, and that was in the headwater of a stream, and that seemed to be the source that was causing problems as far as bacteria levels. But the point I do want to make with this slide is do the inventory as a first step before you develop that sampling plan. You'll have a much better plan if you know what's in the watershed to start with, rather than going out and sampling and then trying to figure out where things are coming from. Once you've got that inventory done, then you can start to set your sample points up so that you can distinguish some of these different sources. So public sewered areas and unsewered areas, they don't tend to intermingle. The public sewer line will go up a creek, out a road to a certain point, then it stops. And so where that public sewer line stops is a good spot for a sample, both to differentiate impacts from failing septic systems and from agriculture. So a good point to have as a sample point is the furthest upstream point on your public sewer service area. It's a little more difficult to distinguish agricultural pasture impacts from rural residential, where the houses are just widely scattered among scattered pastures. But you can look at it and do your best and see what shakes out there. Typically, houses a long way from the stream that are widely scattered aren't going to be the main problems. It's going to be when you have a lot of houses clumped together down by a stream. Okay, so for public sewers, and I'll just tell you, let's see, I've been at going here for about 15 minutes. It's probably about 15 minutes more of my presentation here. So I think I was roughly about a half hour. So calibrate yourself for another 15 minutes of Charlie Brown teacher voice coming at you. All right. So public sewers, again, the extent of the sewered area is a really important thing to know. You don't have to know absolutely what every house is that's sewered, but if you know the extent, how far out the road, how far up the creek the public sewer line goes, that's important. You can look at the TMDL, the pollutant source report should have that information. It may be outdated somewhat by now, depending on which TMDL watershed it is. You know, some of them are 20 years old now, and most places have expanded their sewer lines in that time. You can Google WVIJDC utility GIS, which is the Infrastructure Jobs Development Council. They have a GIS layer that shows areas served by public sewer and water. And again, those may need some updates. So it's always a good idea to stop by the local wastewater treatment plant and talk to them just to make sure that what you've got is accurate. Or you may just want to start with them and start building a relationship. Another thing is where are their extensions planned? See over here in this map on the side, if the yellow sewered area, they were going to extend out into this developed area, and maybe there's already plans on the books, been approved, and they're just waiting on the funding process and the bidding process and all that to go. It may be 2 or 3 years down the road before it's actually online. But if the plans are on the books, maybe that's not the best place to focus on sampling. You wait until the project is done and see what things are looking like at that point. Unless you want to go document improvement, of course. You're going to want to know where the wastewater plant discharge is, if there are pump stations, combined sewer overflow points. All those are important when you're thinking about where to sample. You might, if you're talking to the wastewater plant, also ask about age of sewer lines in particular areas. And again, you're not looking for a map that's listing it out foot by foot, but they may say, oh gosh, you can still see my pointer down along the creek here. We've got 1,500 foot of terracotta pipe that still hasn't been replaced. It was put in the 1950s or something. And you would know, well, hey, that's a potential place there could be some leakage from the sewer line, and set a sample point up accordingly if you wanted to do that. All right, CSOs and manhole overflows. I've got a couple photos on here. So combined sewer systems are sewer systems that combine both sanitary sewage and stormwater. So it's your commode flush plus street drains are in a combined sewer system. And they were originally designed like that before there were wastewater plants, before wastewater plants were being built. And it was just basically a way for the town to get rid of the sewage. They, when a rain came, it would flush the sewage out of the line and send it on down the creek. When they built wastewater plants on the end of those lines, then we started having problems with that excessive hydraulic loading, washing the treatment capacity out of the treatment plants. The bugs that are in there doing the biological treatment. If you get too big of a flow, it'll wash those through the plant, and it may take weeks to build your stand of critters back up there in your treatment plant that are actually doing the real treatment of the sewage. So probably too more detailed there than you needed or wanted, but you can see in this photo the concrete structure up here in the background. Of course, there's the overflow coming out here, but in the ground below that concrete structure is a wet well with pumps in it. So this is a pump station. And the idea, of course, is when the sewage comes in, it fills up to a certain point, the pumps kick on, and it pumps the sewage out and no problem. Well, pumps it onto the wastewater treatment plant. But what happens when in this combined system, when it's raining and you get more water than the pumps can handle, it overflows out the CSO point, combined sewer overflow. And these can be pretty significant. This one, I think, was running roughly 100,000 gallons a day when it ran. And just a rough equivalent there, that's more than 500 straight pipes. And I know of no creek anywhere that has anywhere near that. So these are really significant contributions that you need to at least be aware of and design your sample point around. The CSOs are permitted, and their facilities will have long-term control plans. It's an expensive proposition, but at the very least, you need to know that they're in the watershed. And if you're sampling downstream of there, that could be a major contributor to your bacteria levels. All right, so what if there is no overflow point? What if it's not a true combined sewer system? You can still get surges of flow, and almost always you still get surges of flow either due to people having their roof drains connected to the sewer line, or as mentioned, old pipes that can allow for inflow into the sewer line. So when it rains, you just get excess water coming into your system. What happens to that if there's no permitted overflow point? Well, you get surcharges on manholes. And a lot of times, gravity sewage lines are located right along creeks because that's the low point. Pipes go to that, and then the line will run along a creek for some distance until there's a pump station to pump it to the wastewater plant. If you look at the lids there closer, you can see that's a 150-pound manhole lid that's been displaced by the water pressure. And you can see evidence of sewage overflowing out the sides of it. And this is probably more common than you may realize. But again, it's something that to be aware of when you're doing sample plans, when you're trying to track sources, if there is, especially an older wastewater collection line in your watershed, you can just, by driving around after a rain or even during the rain and seeing if you see any evidence of overflow, that's a good way to find that they're there. So most systems in West Virginia have at least some part of them that are old. And I'm talking about what I've been talking about there tends to be problems with older lines. When they go in with new plastic lines, you tend to not have anywhere near that type of problem. There's still a lot of places around that have portions of the collection line, in the old part of town, that they're working on gradually replacing. And leaks and overflows do occur with those. And I mentioned that type of leak is represented in the TMDL under the urban residential runoff. So I started to say it was kind of quote unquote hidden in the TMDL, but I said, no, I'm not going to say it's hidden in the TMDL. I'm just going to say that it's not obvious. It's not something that you may have been thinking about when you thought of bacteria sources. But if centralized collection systems are present, it's something to consider for sure. All right, so unsewered areas. That doesn't mean there's no treatment at all. It just means that they're not served by a public sewer system. And again, I think most of us are pretty familiar with straight pipes, that idea. A true straight pipe is you're going to see evidence of raw sewage in the stream itself. Toilet paper is the common thing that you see below a straight pipe. And a lot of times you'll see more relief pipes where somebody has an inadequate system and they've just put in a pipe to help drain the water out of their yard so that it doesn't pool up in their yard. And septic systems can fail toward the surface. They can fail downward toward the groundwater. And I say most private systems do function fine, except when there's not enough area for them to work and when they're not adequately designed. And this is just a snapshot from somewhere that you can see as close as these houses are with the hill right behind the house, road right in front of the house. There's just no place here to have adequate septic systems installed. So you've got old houses near a creek and they're closely stacked there right beside each other. And that's the kind of situation with failing septics that's the most problematic. If sewage starts backing up in your house, the wife says, "Hey, call the guy," and so you spend the money to come out and get the problem fixed. But if you get a pool in your yard, puddle in your yard, most people probably don't think too much about it until it gets to the point that they can't drive their lawnmower through it. When the lawnmower starts spinning and they get out and have to walk through it, they think maybe we should do something about this. And rather than saying, okay, well, let's spend $4,000 to fix our septic system and cancel the vacation to Disney World, people are going to just dig a little ditch to drain the puddle away from the property so that they can keep mowing their yard without the lawnmower getting stuck. And you can see the result there. Another solution that people will use is to separate water from a shower, bathtub, washing machine, and to reduce the hydraulic load going into the septic system. So you'll see sometimes these pipes flowing with just suds, and those, if there's no sign of toilet paper or similar materials, you can chances are that's what's going on. They've piped their washing machine and or shower in a separate line out to the ditch line. In theory, that wouldn't contain fecal coliform bacteria. And not that I'm advocating doing it, or certainly the detergents and stuff have negative effects. But I'm just saying that not all straight pipes, so to speak, that you see are actually sewage straight pipe. Here's another one. Doesn't look like it's failing too bad at this point. There's not a big flow of water coming out, but you look, there is dead grass where it's been going on for a while. This is summertime, so there's lots of water uptake. So if you went back and looked at this one in February or April, it might be a whole different story there. Probably what's going on here, this is on a mountaintop, and this is failures probably due to having just a real shallow soil, maybe 2.5 feet on top of bedrock. And there's just not enough soil for an adequate absorption field, even though they may have put out 150 or 200 feet of leach field. And then, of course, you've got some that just go straight out to the creek, drop in, and then they are the true straight pipes. And I'll spare you the close-up. Extent of impact varies depending on the size of the stream, number of sources, whether it's directly into the creek, how far downstream are you from the straight pipe. I'm sure that all makes sense, and you guys know that. I'm just going to touch on a couple more. The idea of the clarity and shade depth, those things impacting. Fecal coliform, E. coli, can be killed by ultraviolet light. And so if there's the shady canopy, if it's water's typically turbid versus clear, shallow versus deep, that makes an important difference in how long the bacteria will survive in stream. Temperature wise, I think I've read about 8 degrees Celsius. I think that's in the 40s Fahrenheit. So once springtime starts hitting, that's kind of prime time for the most bacteria to grow. Colder water or warmer water, bacteria don't grow quite as well, don't hang in the stream quite as long. But then if you have pH issue, if you've got an acid mine discharge going into your stream, that is going to lower your bacteria result as well. low pH and high metals. So generally with these unsewered areas, how old are the houses? How big are the lots? How close are they to the creek? You can drive through, see evidence of failing systems and inadequate systems. You can also talk with county sanitarian. Another person you may not have talked or thought of are the honey dippers, the guys who get the call when there are problems. They will know what parts of the county have problems with their septic systems. The TMDL can be a little bit helpful here because we've already calculated the number of unsewered houses. We have taken into account failure rates, which depend on depth of the bedrock, groundwater, soil permeability, that kind of thing, as well as the distance to the stream. So pastures, not all pastures are bad by any means. There's lots of good pastures that are probably having minimal impact on the stream and definitely not causing violations of water quality standards. When you're out doing this inventory, look for places where the cattle have access to the stream for what I call direct deposit. Feedlots located right along the banks, or this is an area in the headwater of the stream where the photo doesn't show it extremely well, but it's sort of a typical West Virginia stream where you would have steep banks coming down on either side with especially on that far right side and draining right into the stream that's going there. So stream access, winter feeding areas of high slope. That's kind of what to keep an eye out for. If you can't access areas, you can learn a lot with Google Earth. Just looking here, you're able to see the fence lines. This photo, I believe, is from May. So you can see this area here was a winter feeding area. It's trumped down. It's got, where they had their hay bales, and it's unrestricted along the stream. And you can see that was probably either doing something like moving their winter feeding area if possible, or doing a little more buffer along the stream. That would go a long way to help that stream out. So you can see the fences on Google Earth. You can also see cattle if they happen to be in the field when the photo was taken. So these guys are some cattle grazing here. And this photo, I just happened to notice when I was looking at different ages, they have put a fence in along the stream here. And this photo was taken 3 years later than the first one I showed. And they have fenced the cattle out of the stream, and you're starting to see some buffer area grown back, vegetative buffer. And that's the deal. That's what we're looking toward doing, where are these pastures in the riparian areas to hopefully get some management practices installed there that will reduce the runoff potential. If you have a newer TMDL in your watershed, we have already went through and done a pretty good inventory of riparian pasture. And again, it's not visible in the TMDL itself when you link to it, but you can get a hold of us and get this info as to which subwatersheds have the most riparian pasture, which ones would be priority to look at. And that's the list, particularly the Cacapon, Little Kanawha River, maybe the lower Tug has some ag in it, and the Potomac Tribs would probably be the most relevant for agriculture info there. And I'm just about to wrap up here. If you can only do one windshield survey, do it when the leaves are off so you can see better, if that's possible. And if you're able to do another one, I'd recommend doing it at a low flow time. And you can, when the stream flow is lower, you can see signs of enrichment, signs of nutrients in the stream. And if there are a lot of nutrients in the stream, chances are there are some bacteria as well. Okay, just a couple odds and ends, and we'll be done here. It's when you're doing your sample plan, allow for some duplicates, and about 10% of the samples is a good rule of thumb there. blanks and background, again, that's good practice to do. The background, I think, is good to have just for comparison. If you go out and sample in a rainstorm, you may get similar values coming off of pasture as you're getting coming out of the woods. You may not. You may get a lot higher values coming out of the pasture. But I think it's good to have that background value as a comparison, and it might also clue you in if you've got something else going on, maybe some contaminated sample containers or problem with the analysis or something like that. If you're getting a lot of hits in low flow background site. And one more important thing here is comparing base flow and high flow, a rain event sample. So it's kind of good to know maybe that with public sewer collection line, you'll get your high values. This is common sense when you stop and think about it. High values are going to indicate that there's leakage in old lines, or maybe there is a house that is connected to a storm sewer instead of the sanitary sewer line, a cross connection. Whereas if you get high values during a rain event, that's going to indicate overflows, bypasses, that sort of thing. So it's good to have samples at both base flow and higher runoff periods. And you can get at base flow high values from failing septic systems, from pasture, from collection lines. So it just kind of points to the idea that it's important when you're doing your sample plan, if at all possible and as much as possible, separate out geographically these types of source categories so that your sample will can distinguish where the real problem is coming from. Okay, what about DNA samples for bacteria? In our group in the TMDL section in the watershed assessment branch, we used to be known as, we haven't used those, we don't use them. There's a study from USGS. It's getting a little bit old now, and but that showed there is some good stuff in the DNA samples, but when the study was done, they were not quite reliable fully, and they've come a long way. I think they're improving. There's the qPCR test now that's better. So I feel like it's improving. I was just looking at some results from a watershed group a couple of weeks ago, and their DNA results overlaid pretty well with our source tracking work, where they said there was bovine DNA. We were saying, yeah, there's a lot of unmanaged pasture in that creek. Where they were saying there's a lot of human DNA. That's the main thing. We're not seeing pasture in that creek. And so it overlaid really well, except in maybe one creek. And so it seems like it's pretty good, improving, but not far enough yet that you can just go grab a sample and say, yeah, that's the deal there. That's what's going on. It's also probably 10 times roughly more expensive than a standard bacteria sample analysis. So you've got to weigh that as well. Is it going to tell me more if I can go do 10 samples in a strategic location or one sample? As the old, the salesman said it works, it must. Well, maybe like I say, it's come a long way. I'm not sure it's quite there yet. I would like to see a new study on that, and maybe someone can send one that they know about that has some updated information on it. But I'll just mention here at the end, you can't argue with photos. If you go out doing these inventories and there are manholes that are overflowing, there's straight pipes, there's cows standing in the creek, these are obvious problems that we ought to be working toward reducing those particular problems. And in the end, that's all going to add up. And those are just real problems that you can look at and say, okay, that needs fixed. And All right. And I'm just going to mention, since public sewer systems can be potentially such large contributors to bacteria levels, we've seen the most success, I think, where public sewer systems were installed or extended or upgraded in some way or the other. So that makes sense. Lost River improvements, ag related, I went back and pulled some data from Department of Agriculture, which has monitored the Lost River at least since 1998. And they've done lots of work over there in that last 25 years. But I looked at 5 years worth of data on the front end of that, so 98 through 2002, and then from 2018 through 2023, and their overall values for bacteria had cut in half on average. Just a really rough all samples 5-year average. So there's definitely some improvement that's been made through the agricultural BMPs and all the work that's been done over there in the Lost River Basin. And we've got some work coming up. I think there's actually something going on now with Second Creek in Greenbrier. So I'm going to end with that and leave my contact info on the screen and turn it back to Martin and Autumn to take questions.
Thank you very much, James. The floor is open for questions, and we have one that's written down. Autumn, would you like to throw it out? I mean, pose it.
Sure. So the question is about karst. Can consideration be given to karst or epikarst geology when determining the impact of leaks from older public systems? These can allow underground transport of contamination to streams.
And I think the short answer is yes, with the idea that probably in most cases, it's probably not as big a factor. I'm just kind of throwing that out, that it's not as big a factor as in karst as you might think. I think most, Charlestown may be an exception. There may be more exceptions than I know about. Berkeley County's lines are strung out all over the county now, but again, those are newer lines. So as far as the karst coming into play, karst just greatly complicates everything, as the person asking the question knows. And short of dye studies and that kind of thing, it's hard to know for sure what's going on. And even with dye studies, it's things can change with groundwater levels and all sorts of things. And I'm not giving a very good answer here, I know, because it's a tough question to tackle. But I think where I was coming at from the beginning there, you can still do, even if it's in a karst area, you can still do a lot of work. Unless the stream is known to be sinking, you can still, or unless it completely sinks, I would say, you can still do a lot of source identification work with sampling in karst areas, just with the amount of water that remains in the stream channel and is flowing on through. There are obvious complications too if you've got water coming into the stream from springs from other areas, and that's and I'm sure you probably are aware of the source, but West Virginia Karst Atlas is a good source of information that summarize dye tracing and map that. So that's a good source of information to get a hold of if you don't have that already. And it's going to show sinkholes and where those sinkholes have been mapped to certain springs. And a lot of times, especially in the Eastern Panhandle, I don't know if you're talking about the Greenbrier karst or the karst in the Eastern Panhandle, but in the Panhandle in particular, things are just much more complicated up there because of the way the the fracture and dissolution has occurred, and so you get a lot of not just straight line between one sinkhole and one spring, but you can have multiple springs tied to one sinkhole and multiple sinkholes tied to one spring. Sorry if I didn't help you much, but the West Virginia Karst Atlas would be my best advice there.
Thanks, James.
We have another question. You mentioned that honey dippers may know more about failing septics than anyone. Can you explain to everyone who or what a honey dipper is?
Okay, good question there. Yeah, honey dippers are septic tank pumpers. And so if someone has a problem with their septic tank, that's who is going to come out and pump it. And so honey dipper is a septic tank pumper. And you can just look in the yellow pages. Does anybody still use yellow pages? I must be old. But that's the best place to look probably to find a septic pumper in your area.
So there's another question here. How many more Jameses do we need to bring into DEP to get caught up on bacterial contamination TMDLs? How many years of backlog are there?
There's, as far as backlog in the source tracking for the TMDL, I mean, we have stayed up with that, with what we can do. You could certainly always do more in-depth work. The type of work where the TMDL program is heading now, I'll just maybe go into that a little bit with this question. The TMDL program has been on schedule with the state watershed framework. And so we have essentially went almost everywhere in the state doing a TMDL to every watershed in the state except for a couple. And we are finally to the point of coming back around on some of the ones we have done before. And we are evolving, I guess is the best word there, in how we approach TMDLs. We're going to, I think, gradually, in some way or the other, move away from doing these large-scale TMDLs on basins, and we're going to be looking in smaller watersheds and be able to do more detailed source tracking, and get hopefully some more real-world solutions. You know, whenever I did source tracking, let's say in the West Fork TMDL, West Fork of Mon River, you know, I didn't walk sewer lines in Clarksburg looking for overflowing manholes. We just let the model kind of pick up that kind of thing. The model would assign loads back to agriculture or failing septic systems, residential runoff, more house driven. And if there was a calibration problem, if the stream is showing more bacteria than what the model was outputting at that point, then they would turn up the residential knob, which includes that portion of leaky sewer lines. So let's say in a lot of the TMDLs, the bacteria source tracking for that particular thing, the leaky sewer lines, was basically done by the model. If looking at failing septics and problem pastures didn't reach the problem, then they would just essentially turn up the knob and it would be assumed to be there. But if we go to this different approach where we're looking at smaller areas in more detail, you know, we've got the flexibility, the ability to go out and really look and say, okay, there's a pump station here at the corner of 4th and Main that overflows 53 times a year. That's a significant problem that needs to be reduced. So how many more people are needed? I don't know. I would love to have one additional one to train before retirement catches up with me.
Thanks, James. You've accumulated quite a bit of knowledge there thank you for sharing it. with us. I think that's all the time for questions for James that we have. I know there's one more question in the chat, but maybe we should go ahead and let Martin present. And then if we have time at the end, we can answer that last question.
And certainly email me if a question comes up later or this one doesn't get answered. Give me an email or text or call. My contact information is there.
So Martin?
All right. Let's see if I can find the correct screen.
And for those of you that don't know Martin, Martin is the Northern Basin Coordinator in WVDEP's West Virginia DEP's Watershed Improvement Branch. He helps administer Stream Partners grants and EPA non-point source pollution grants. He likes to work on acid mine drainage problems as well. And his presentation is entitled The Case of Bull Run.
Right. I don't see my screen showing. I see your face, Autumn.
It's showing. I can see it.
All right. Zoom works for me until it doesn't, I guess.
Maybe that will help.
All right. Okay, well, yeah, I want to drop a few things in the chat, but I don't see the chat thing. My colleagues are all saying, Martin, you boomer. All right, well, so it goes. Oh, here we go. That's better. Okay, so I've played around with the title, and I guess I thought it was more exciting to say that a step system might be right for Bull Run. I'm going to start with some perspective and disclaimers. I'm in the Watershed Improvement Branch, works with the Nonpoint Source Program, and our job in the Nonpoint Source Program is to make streams meet standards. We like to multiply flow times concentration to get loads, and we like to make maps of watersheds. What we're looking to do is find ways to install best management practices that will reduce the loads of a pollutant such as fecal coliform from non-point sources. Another thing that the non-point source program does is encourage partnerships. So there have to be partners who help with money, often state and federal agencies. There have to be partners who do the legwork to put things together, and there have to be partners to do operation and maintenance. What got me interested in this topic is the idea of trying to put together holler-sized sewage treatment systems. So, 10 to 20 houses, not big towns, but something smaller that would take care of the pollution in an individual stream. And I have to say that this is not a topic I know about a lot about. Fortunately, we do have people who are coming on who do. Next week, Dennis will be back, and Dennis and Samuel Urban from Trout Unlimited will talk about agriculture BMPs to help reduce fecal coliform. The week after that, Barry Milam and Rick Hurtjes will talk about systems. Barry was a PSD operator for a long time, and he had a front row seat of people trying lots of things. I think some of them worked. Rick Hurtjes is with the Bureau for Public Health, and he'll have a lot more input on cluster systems and what to do when the soils aren't right for septic tanks and leach fields. Tim Craddock, of course, is the coordinator of the Nonpoint Source Program, and Kathy Emery is the director of the Clean Water State Revolving Fund, and that is the part of DEP that actually does put in sewage treatment and moves things along. I'm giving you homework. This is one reason I wanted to have the chat available. I'm giving you homework to go to YouTube and search Environment Matters and Leatherwood. And this is also the link here. Okay, so I want to focus on Bull Run. And everybody in West Virginia says, which Bull Run? And I say this one. It is in the Tiger River watershed. Of course, landmarks in the Tiger starts near Snowshoe, goes through Elkins, receives the waters of the Middle Fork and of the Buchanan River, goes on through Philippi, Tigert Lake and Grafton, down to Fairmont, where my office is, and there joins with the West Fork to make the Mon. Part of the Tigert watershed is the Buchanan River watershed. It has Helvetia as a landmark. I put a Swiss flag there because my dad was Swiss. And that star represents the home of my friend, French Creek Freddy, who predicted an end to winter. This is French Creek here, of course, and this is the French Creek watershed about halfway along Route 20 from French Creek to Buchanan. You see this red dot, and that is Adrian, and that is the mouth of Bull Run. And this is the Bull Run watershed. What's special about it is that several members of the Buchanan River Watershed Association either call it home or care about it. And those are both good reasons. It has 3 named tributaries and 3 unnamed tributaries. And if you add tribs to tribs, the Water Quality Standards and Assessment section has assessed Blacklick, the main stem, and Mudlick. Blacklick, they found, fails to meet standards for total iron, dissolved aluminum, and pH. It is an AMD stream, and the Office of Special Reclamation has been working on it. The next time the assessment section gets out there, it may be a lot better. Bull Run and Mudlick Run both failed to meet standards for fecal coliform, total iron, and dissolved oxygen. They seem to be wastewater problem streams. Bull Run also fails to meet the CNA bio standard. And just to make sure everybody knows what that is, CNA means condition not allowable. And it's not referring to bio as in microbiological and bacteria. It's referring to bugs. The condition not allowable narrative criterion says that sewage or other wastes shall not cause or materially contribute to any of the following, such as it should not cause a significant adverse impact to the biological components. So that's all about WIVSKI or bugs. And I was going to say, all of you fans of benthic macroinvertebrates, put in a thumbs up, but in fact, I don't think you can do that on Zoom. Okay, so the assessment section went on to figure out where the loads were coming from in the subwatershed. They divided it up into 4 subwatersheds and gave them these charismatic numbers, 3064, 3065, 3066, and 3067. And as James mentioned, these are in a spreadsheet, and they're and you can download this right off of the DEP web by going to dep.wv.gov and search for TMDL. The spreadsheets look like this, and there's a sheet that James also showed, LA fecal, the load allocation for non-point source for fecal coliform. And in the case of Bull Run, I filtered it down to 3064, 3065, 3066, and 3067, and found that there was no allocation for reductions from cropland. For pasture land, there should be reductions of 92 and 92.6 and 92.1%. There's no allocation for background non-point sources. And as James said, for on-site sewer system, the DEP in their TMDL says, got to reduce all of it. And residential percent, what James mentioned should include leaky sewers and stuff. There is none. And there is no sewage, and that there is no public sewage treatment. Well, there might be some right in the town of Adrian, or that might be a collection system. I don't know. But if you look at these, if you look at the numbers, you find that the furthest downstream has a substantial load to be reduced, but the furthest upstream, the 3067, has by far the largest. And I repeated this graph, but I separated it out between pasture and on-site sewer. And according to the TMDL data, the on-site sewer is just a tiny, tiny thin blue line on top of the pasture. Well, Buchanan River Watershed Association wanted to know more. That this subwatershed also is obviously the largest, so it was worth exploring more to see where all that was coming from. We divided the watershed up into 10 subwatersheds rather than 4, and we took a sample at the mouth of each of them. And we did find some hot spots within the within that big, large subwatershed that's upstream. The hottest was what we call the unnamed tributary to Bull Run at River Mile 1.83. It had over 6,000 counts per 100 milliliters. And the second highest was the main stem upstream from River Mile 2.68. This 1990 here, obviously also a large number, is the unnamed tributary to Bull Run at River Mile 2.68. So this is along the main stem upstream from River Mile 2.68. This confluence, or Bull Run just upstream from the confluence of Mudlick Run, also has a high number. We figure that it's inheriting a lot from the unnamed trib at 1.83. So we took a closer look at the unnamed trib at 1.83. That's this blue subwatershed here. And it does look like there's a lot of pasture there. You can see a lot of green areas, some less green than others, maybe more disturbed, right along the stream. And if you drive along, you do see some grazing right along those. On the other hand, if we look at the area that is upstream from River Mile 2.68, there's also some green grass right along the stream, but you can also see there's quite a lot of houses right in there. So it's clear that if the people of the Bull Run watershed want to clean up the streams, it's going to take a lot of ag work. And we'll hear more about that from Dennis and Samuel next week. But now I'm zooming in on the houses in the area of Abbott, which is that area upstream from River Mile 2.68. And you can see that the lots are relatively small. It may be hard to fit in septic systems there. We've talked to people and they say, oh yes, we have septic tanks and leach pits. I think their systems are fairly old and may need some help. In addition, if you look at the soils map for that area, you can see that a lot of it is mapped to the Orr-Hawley soil series, which is known to be shallow to groundwater and also doesn't perk well. And those are both strikes against using the land for leach fields. especially unsuitable for leach fields. So what can you do in an area like this? And Nonpoint Source, we get excited when we hear of new gizmos that may help. And I am going to talk about a gizmo that's not at all new, but it was new to me when I heard it. A traditional suburban area might include a number of houses, and each house will have their own septic tank, and each septic tank may drain to its own little patch of ground for a leach field. I apologize, I found an image of dumpsters rather than septic tanks. Well, you could work it this way instead. You could have several houses drain to a single septic tank and have that septic tank drain to a single leach field. And the tank and the leach field would probably have to be bigger, but if you're moving things a little bit of distance, it may be possible to find that kind of land. Well, then another possibility is you take that water from the septic tank and you pump it up the hill or somewhere far away where the leach field isn't so close to the river. And then if you get really fancy, you can pump the effluent from your septic tank into an effluent treatment system and then let that drain into a leach field. So that seems to be a nice, convenient way that you could do something to get the sewage out of the creek. And this is a well-known thing. If you pump it, it's called septic tank effluent pumped, or a step system. On the other hand, if you find a place where you can drain it to just by gravity, you have a septic tank effluent gravity system. And there are some advantages to it. You're not pumping solids, you're pumping liquids, so it shouldn't wear out expensive grinder pumps all the time. You don't have solids, so they won't settle out in the low places in the pipes, although you could throw in a few traps to help the system. For effluent only, you can use relatively small diameter pipes, and at least according to the people who advertise these things, these smaller pipes can follow ground contours. So you can just pump it along the road and not put in an 8-inch pipe directly through a hill if the hill happens to be in the way, going at grade the whole way. Of course, your tank would need a lot of regular maintenance pumping, and you would need electricity for the pumping. So I've worked with watershed groups. I worked for one before coming to the DEP. And to me, it sounds like, hey, we can do that. Watershed groups can do that. I've seen watershed groups who evaluated and built community support. I've seen them, secure funds, hundreds of thousands of dollars, even more. I've seen them hire engineers. I've seen them purchase land. I've seen them write or get from engineers operation and maintenance plans. I've seen them as they hire and oversee construction contractors and take on operation and maintenance responsibilities. I haven't seen them yet establish entities to collect monthly fees and be responsible for O&M. And, that may or may not be really their role. But this was obviously time to back off because there's a lot of steps we haven't taken. I've gotten the cart way ahead of the horse. We're just the watershed group and I are just now reaching out to the community. We had a plan to do so, but that little COVID thing came along. So we're reaching out a lot now and thinking about, well, what do we actually know? Those numbers that I showed are from just one sampling run. I want to say we're not reinventing the wheel. Step systems are well known. And there are a lot of partnerships that work on these, including rural PSDs, development councils, Clean Water State Revolving Fund, and so on. Nevertheless, I am talking about STEP and STEG systems because I think they should help a lot in the big picture for the state. In the meantime, Buchanan River Watershed Association is doing a lot of outreach, including a potluck in the community next week. The message will be that the Watershed Association wants the stream to meet standards, wants to see if residents want it, and if residents will lead it. There's a commitment to no finger pointing. We don't want the people in the houses saying, oh, it's the people in the pasture, it's the cows in the pastures. And we don't want the, excuse me, we don't want the farmers saying, oh, it's all those people in Abbott. We think that we'll be able to find resources one way or another, and we're asking people if they will help, if they will monitor, if they will allow monitoring in the backyard, if they will join the watershed organization and lead. And by the way, Buchanan River Watershed Association is also offering some support for pumping septic tanks. There is an example of a STEP system that the Nonpoint Source program got involved with. Barry, who's here, may say a bit about it in a couple weeks. This is in Ashland on the Windmill Gap branch of Elkhorn Creek. They built a series of tanks in the town at an elevation about 2,100, and they pumped the effluent about 4/10 of a mile away up to more than 2,500 feet. And the project had some trouble with pumps breaking down, but hopefully the operations and maintenance entity is a little bit more beefed up now. And I'm going to put more information in the chat on that if I can. It's not going to be easy. We all know probably nobody wants more bills, and if it's going to give monthly bills to people, that's definitely going to be an obstacle. Once you take you take a bunch of people's sewage and treat it, you're regulated by the Public Service Commission. That could be a hoop. And then, of course, there's regulation by us at the DEP, NPDES permits, and underground injection control permits. And there's probably more. There's a picture of the creek. The part coming in from the right, you can see is a little bit cloudier, and that's the main stem. What's coming in from the bottom is Newfound Run, which wasn't assessed by the assessment section, but BRWA has found that it has bacteria. And this is just a picture of pasture on the unnamed tributary at River Mile 1.83. And that's a decently pretty picture, so I'll end there.
Okay, well, thank you, Martin. And we wish good luck to Bull Run and the Buchanan River Watershed Association as they tackle this problem. I don't see any questions in the chat. Well, oh yes, we do have a question. Will the slides for these presentations be available? And yes, we can send the slides out with a copy of the recording. Another question, would above ground peat moss septic filter system be of any help in Abbott?
It may do the trick. It would get the water from the septic tank a little higher, give it more media to work in rather than getting to the water so quickly.
Okay, well, if we have 5 minutes, so we can go back to the previous question. And I believe this one was for James. Would testing for caffeine or sugar substitutes be reliable to determine human contamination?
definitely not an expert there in this. I do know that caffeine has been used. I think there's research on it that I'm familiar with that has said that it is a reliable way to detect um, human sewage because caffeine use is just so prevalent. So I think it is a reliable way to detect human impact or the presence of human impact. There's probably in potential cost issue there. I would think you would need to go down in really low a really low analytical zone, maybe beyond micrograms to nanograms, that kind of level. So I don't know what the cost would be, in the real world to implement that kind of thing. So that's it. Yeah, I think it's usable, but I don't know how much it costs.
All right, thanks, James. We have one more question. Compared to other tribs in Upshur County, where would Bull Run fall on a contamination scale?
I will look at DEP data and answer the questioner. I think it's probably within, it's somewhere in the middle of the pack.
Okay, well, those are all of our questions. So I think we can conclude the webinar now. Thank you to everyone for joining us today. The next session of this webinar series will be next Thursday, February 22nd at 2:30. We'll be hearing from Dennis Burns, formerly of West Virginia Conservation Association and now with West Virginia DEP, and Samuel Urban with Trout Unlimited. And they'll be talking about the science of fecal coliform controls and agricultural best management practices. So if you aren't already, make sure you are registered for next week's session. We'll put the registration link in the chat. And make sure that you're signed up to receive the West Virginia Watershed Network quarterly newsletter, the WaterNet. And we can put the registration link for that newsletter also in the chat. And lastly, if you have any other topics you'd like the Watershed Network to host trainings for, please send me those ideas. And my email address is acrowe, ACROWE @wvrivers.org. And I can also drop that in the chat. With all of that said, we thank you so much for attending today, and we hope to see you next week. Thanks, everyone.
Thank you, Autumn.